So picture this. You walk into a coffee shop, and someone at the corner table pulls out this stunning, beautifully machined aluminum laptop.
Mhm.
It's impossibly thin, and it comes in these wild, really saturated colors. We're talking like a vibrant citrus, a soft blush, or a really deep indigo.
Yeah, they really do look like a premium high-end piece of technology.
Exactly. But then you look at the receipt. It cost $599. Or if you happen to be a student, just $499.
Which is just wild.
Right. And here is the kicker. Beating inside this cheap entry-level laptop is the exact same A18 Pro chip that runs inside the $1,000 iPhone 16 Pro. This is simultaneously impressive and completely ridiculous.
It really is a fascinating contradiction,
Yeah.
You're looking at a device that completely upends everything we've been conditioned to expect from budget computing over the last, well, 2 decades, really.
Oh, totally. And that's exactly what we are doing today. Welcome to the deep dive. We are looking at this massive stack of sources you all shared with us. We've got reviews from PC Mag and Tom's Guide and iFixit Teardown, accessory guides from Ugreen, and even some supply chain leaks from McRumors.
It's quite the pile of data.
It is. And our mission today is to figure out what this new 2026 Apple MacBook Neo actually is. Because on one hand, giving someone an iPhone 16 Pro brain for under $600 feels like the ultimate democratization of technology.
Right.
But on the other hand, when you look closely at some of the compromises they had to make to hit that price point, you have to wonder if it's just like a ticking time bomb.
Yeah, and the stakes here are surprisingly high for the broader tech industry. I mean, historically, Apple has always priced people out.
Oh, definitely. The Apple tax.
Exactly. If you wanted into their walled garden, you paid the premium. But the Neo rewrites the budget laptop playbook entirely. It forces us to examine what happens when a trillion-dollar hardware company decides to aggressively target the absolute bottom of the market.
So let's start right at the heart of the machine. Because to understand what the Neo actually is, we have to look at what's beating inside it. And it is not a traditional computer processor.
No.
It's literally a phone brain in a laptop body. I was reading through the PC Mag review you sent over, and they explain this concept of binning to explain how Apple's pulling this off economically. I find the manufacturing logic here so cool.
It really is one of the best-kept secrets of silicon manufacturing.
All right, so basically producing these microscopic, cutting-edge smartphone chips is incredibly difficult and imprecise. It's like baking a massive sheet of cookies. No matter how good your oven is, sometimes a cookie on the edge comes out slightly burnt or misshapen.
Yeah, they don't yield 100% perfect chips every single time.
Exactly. So Apple has these A18 Pro chips rolling off the iPhone 16 Pro manufacturing line, and occasionally maybe one of the 6 graphics cores just doesn't pass their extreme quality control tests.
And in the past, or, in less efficient supply chains, that entire piece of silicon might be discarded as waste.
Which is crazy to think about.
Right, but instead of throwing a highly advanced chip in the trash, they bin it. They permanently disable that one imperfect GPU core, leaving a perfectly functional 5-core GPU, and they repurpose it for the MacBook Neo.
It's an exercise in supreme supply chain efficiency.
It really is.
But I have to push back on this a little bit. Are we really talking about this as a viable laptop? I mean, is this basically just a giant iPhone with a keyboard attached?
Well,
Because putting a smartphone chip into a laptop chassis feels like dropping a high-revving motorcycle engine into a heavy-duty minivan.
okay, I see where you're going with this.
A motorcycle engine is built for quick, short bursts of speed, whereas a laptop needs sustained, heavy-lifting torque. If I drop a Fanless phone chip into a laptop, it fundamentally shouldn't have the thermal capacity for sustained computing.
Yeah, on paper, that makes sense.
Plus, it only has 8 gigabytes of unified memory, and you literally cannot upgrade it.
What's fascinating here is that the architecture actually crushes the competition,
Yeah.
defying that exact logic, that motorcycle engine in your analogy.
Yeah.
It happens to be so ridiculously efficient that it doesn't generate the heat a traditional laptop processor would. And the unified memory is the key to why it feels so fast.
Okay, explain that, because 8 gigs sounds tiny today.
Well, why is 8 gigabytes of unified memory different from 8 gigabytes of traditional RAM? Because in a traditional budget Windows laptop, your RAM is on a separate stick.
Right.
Data has to physically travel across a motherboard bus from the processor to the memory. That takes time and power. Apple's unified memory is baked directly into the silicon of the A18 Pro chip itself. The travel time for the data is effectively zero.
Which explains the benchmark scores. PCMag's Geekbench tests showed the Neo's single-core performance actually beating out traditional budget Windows, Intel, and ARM laptops.
Yeah, like the Acer Aspire Go 15.
Exactly. And it's not just doing basic web browsing either. Because it's the A18 Pro, it has a 16-core neural engine built into it. So it is running local Apple Intelligence features seamlessly.
That's the real game changer here.
We are talking about the new writing tools or the photo cleanup where you just seamlessly erase a car from the background of your picture. And all of that is processing locally without pinging a cloud server on a $599 machine.
It's a total paradigm shift.
Yeah.
I mean, most laptops in this specific price tier struggle to open 10 browser tabs without the internal fan sounding like a jet engine taking off.
Kat, I've owned those laptops. They get so loud.
Exactly. But the Neo handles complex local AI models in total silence.
Okay, but if they are practically giving away a premium chip to hit that $599 price point, they have to be clawing that money back somewhere.
Oh, absolutely.
This brings us to the art of the compromise. We have to talk about the hardware cuts because some of them are very intentional and honestly quite bizarre.
The spec sheet definitely reads like a study in calculated deprivation.
Let's start with the obvious ones. There is no MagSafe charging. That satisfying magnetic breakaway charger we all love, gone. Keyboard backlight on the base model, non-existent. If you want to type in a dark lecture hall, you better learn to touch type.
Which is tough for a student laptop.
Right. Touch ID, nope. You have to type your password manually every time you open the lid unless you pay a $100 upcharge to get the fingerprint sensor.
Although, to be fair, that $100 also doubles your storage to 512 gigabytes.
Which is actually a surprisingly generous storage upgrade for Apple's pricing tiers. Usually they charge you an arm and a leg for storage.
It really is.
Okay, but here's the thing. We have to talk about the port situation. You get exactly 2 USB-C ports, and they are both crammed onto the left side of the machine. One of those ports is a 10 gigabit per second USB 3.2 port. Totally fine, totally modern.
Right.
Wait, it gets better. The other one, the port sitting literally right next to it. It is a retro 480 megabit per second USB 2.0 port.
The infamous right side port on the left side of the machine.
I love that this exists, but also why? USB 2.0 is a relic. It's from the dial-up era.
I know, it's pretty funny.
Imagine buying a brand new laptop in 2026, plugging your external solid-state drive into the slightly wrong port, and suddenly your file transfer window pops up and says, estimated time, 47 years. It makes no sense.
It sounds absurd, but if we connect this to the bigger picture, it actually makes perfect, ruthless market sense.
Okay.
Apple is engaging in strict feature scarcity. They are meticulously protecting their premium MacBook lines.
Yeah.
If you're a professional who wants dual external monitors or Thunderbolt data speeds, or if you just want to plug in 2 high-speed devices simultaneously,
Yeah.
Apple is setting up an invisible fence. They're politely telling you this machine is not for you. Please go buy the $1,099 M5 MacBook Air.
Wow, that invisible fence is so real. Ugreen, the accessory maker, put out a whole guide for this laptop.
I saw that.
Yeah, they pointed out that the Neo's primary USB 3 bandwidth physically maxes out at roughly 450 megabytes per second.
Oh.
So if you go out and buy a fancy $200 Thunderbolt docking station to try and force this cheap laptop into a pro workstation, it is completely useless here. You are hard capped by the silicon limitations Apple intentionally put in place.
It is brilliant market segmentation. They give you a beautiful design and a lightning-fast processor so you fall in love with the machine.
Right.
But the moment you try to push it into professional workflows, you hit a brick wall.
So they ruthlessly protected the Pro line with those port speeds, which makes you wonder, why didn't they just put a garbage screen on this thing to save even more money?
That is the traditional budget playbook usually.
Right. Usually a $600 PC laptop has a screen that looks like you're viewing it through a foggy window and a battery that dies before lunch. But the Neo shockingly over-delivers here.
This is where Apple's massive economies of scale come into play. They aren't inventing a cheap screen from scratch. They are likely repurposing display manufacturing lines from older premium iPads.
The specs on the screen are wild for this price. It has a 13-inch liquid retina display. We're looking at a 2408 by 1506 resolution, 500 nits of brightness, and 10-bit color depth.
Yeah, the 10-bit color is huge.
I have to ask, though, why does 10-bit color matter to a college student just typing an essay?
Well, it matters the second they stop talking and open Netflix. Most budget laptops use 8-bit color panels, which can display about 16 million colors.
Okay.
10-bit color can display over 1 billion colors. It means when you are watching a movie with a sunset, You don't see those ugly, blocky bands of color in the sky.
Oh, I hate that banding.
Right. With 10-bit, the gradient is perfectly smooth. PC Mag noted it absolutely blows away the muddy 1080p screens you usually find in this budget tier.
And the battery life is just as impressive. Tom's Guide ran their continuous web surfing test, locking the screen at 150 nits of brightness.
How long did it last?
The Neo lasted 13 hours and 28 minutes.
That's incredible.
It crushed competitors like the Microsoft Surface Laptop Go 3, which barely scraped past 8.5 hours.
Wow.
But the real no way moment for me was the iFixit teardown. Because for the last decade, MacBooks have been notoriously impossible to repair.
Oh, they were a nightmare. Glued-in batteries, proprietary pentalobe screws.
An absolute nightmare. But iFixit gave the Neo a 6 out of 10 repairability score. They called it the most repairable MacBook in 14 years.
The internal engineering of the battery tray is a total revelation.
Yes. No more glued-in batteries. The battery sits on a tray held into the chassis by 18 individual screws.
18 screws.
Seriously, of course they used 18 screws. But I have to push back here. Why does Apple suddenly care about repairability on their absolute cheapest device, while the $3,000 MacBook Pros are still practically glued shut? Is this just an environmental marketing flex?
Well, it serves the environmental marketing, sure. I mean, the Neo uses 60% recycled materials by weight, which is an Apple record.
Okay.
But it's actually an engineering necessity driven by physics. Think about how thin the aluminum chassis on the Neo is to keep costs and weight down.
Right, it's incredibly thin.
Because it's so thin, the laptop lacks structural rigidity. If you press down on the keyboard, the whole motherboard would flex, which breaks components.
Oh, that makes sense.
Look closely at the design of that battery tray iFixit uncovered. It features a full-length stamped rib. By using 18 screws to lock that solid tray directly into the weak aluminum frame, the battery tray becomes a structural cross-member.
Wait, really?
Yeah, it is literally acting as the spine of the laptop. They solve two problems at once. They reinforce the keyboard deck so it doesn't bend, and as a byproduct, they made the battery easily removable.
That is incredibly clever engineering. It represents this rare moment where sustainability, repairability, and structural integrity all perfectly align.
Exactly.
So it's solid, it's repairable, it's a wonderfully thoughtful, everyday machine for a student, which naturally means the tech community immediately tried to destroy it.
Of course they did.
We just can't leave a budget machine alone. We have to push it to its absolute breaking point.
It is an undeniable law of human nature. If you give us affordable hardware, we will try to hot rod it.
We really do. So it has an iPhone brain, right? It's meant for essays and web browsing. But PC Mag actually got the notoriously heavy, graphically intense AAA game Cyberpunk 2077 to run on this fanless machine.
Which sounds impossible.
They used Apple's frame generation technology, dropped it to the absolute lowest settings, and got 52 frames per second. How is a fanless phone chip running Cyberpunk at 52 frames per second?
Well, the key there is frame generation. It's an AI trick.
Okay.
The chip isn't actually rendering 52 individual fully realized frames every second. It renders frame A, and it renders frame C, and then it uses the neural engine to intelligently guess what frame B should look like, interpolating the motion in between.
Oh, wow.
Yeah, tricks your eye into seeing smooth gameplay without taxing the core graphics processor to the point of overheating.
But if you want to talk about overheating, the crowning detail of our research comes from a tech YouTuber named ETA Prime. This is just wild.
I love this part.
ETA Prime opened up the bottom of the Neo, ripped off Apple's basic graphene thermal pad, and attached a custom copper heatsink directly to the A18 Pro chip. Then he took a massive liquid-cooled Peltier unit and strapped it to the bottom of the laptop.
For anyone unfamiliar, a Peltier unit relies on thermoelectric cooling. You run an electrical current through two different conductors, and it forces heat to move from one side to the other.
Right.
So one side gets blazing hot, and the side touching the laptop gets freezing cold. It forcibly pulls heat away from the chip, completely overriding the limitations of a fanless design.
That's actually genius. But visually, it is hilarious. It's like strapping a jetpack onto a golden retriever.
That is the perfect analogy.
Like, yes, it is highly effective. The dog is soaring through the sky. But a golden retriever is meant to fetch tennis balls, not break the sound barrier.
Exactly.
It completely ruins the entire aesthetic and purpose of an ultra-portable, thin and light laptop.
But it worked.
The results are undeniable. The chip temperatures dropped from 105 degrees Celsius down to a chilling 74 degrees. With the thermal throttling removed, the Geekbench multi-core score shot up 20% to 9,394. And he got the game No Man's Sky to run flawlessly at a stable 80 frames per second.
This raises an important question, though.
What's that?
If bolting a massive thermoelectric liquid cooler to this chip yields a sudden 20% performance boost, it proves something vital. The A18 Pro silicon itself is incredibly powerful.
Right, the chip isn't the problem.
Exactly. The chip is not the bottleneck here. The fanless chassis design, the aggressive thermal throttling, and that unupgradable 8 gigabytes of unified memory. Those are the strict bottlenecks Apple intentionally built around the chip to keep it in its lane.
What does this say about us as a society, though? Engineers spent thousands of hours meticulously designing this perfectly balanced, silent, ultra-portable machine for a college freshman. And our very first instinct is to rip the back off and strap a literal refrigerator to it just to see if we can play a video game on it.
I think it says that we are fundamentally obsessed with untapped potential.
Totally.
We want to know the absolute limits of our technology, even when extracting that potential is utterly impractical. But that raw untapped potential is actually leading directly into what supply chain analyst Tim Colpin calls Apple's current massive dilemma.
Right. I read that MacRumors piece. Sales of the Neo are surpassing all internal expectations.
They're selling incredibly well.
They are actually having to boost production lines in China and Vietnam because the consumer demand for a $599 Apple laptop is so high. But there is a shadow looming over this success, and it comes back to that 8 gigabytes of memory.
It is widely considered the ticking time bomb of this generation of MacBooks.
Because of the evolution of Apple Intelligence, right now 8 gigs of memory is totally fine for web browsing, writing emails, and basic on-device photo cleanup.
Right.
But as these local AI models get more advanced and require more memory to run on-device, 8 gigabytes is going to hit a wall fast. And the MacRumors leak says next year's MacBook Neo is already expected to use the A19 Pro chip, paired with a minimum of 12 gigabytes of RAM.
Which perfectly aligns with the mechanical requirements for future AI workloads.
How so?
Well, large language models require significant amounts of RAM just to hold the model's parameters in active memory before they even start generating text or analyzing images.
Oh, I see.
If the RAM is full, the AI simply cannot run locally. It has to offload to the cloud, which ruins the whole localized speed advantage.
So what does this all mean for you, the person listening to this right now? You're sitting there looking at your aging, slow laptop. You have a budget of around $600. Do you buy the MacBook Neo today, accepting its 8 gigabytes of RAM and its weird dial-up era USB 2.0 port?
That's the big question.
Do you wait out the ticking time bomb for next year's rumored 12 gigabyte model? Or do you just spend the exact same amount of money on a desktop Mac Mini?
It ultimately comes down to understanding your own computing habits as clearly as you understand the machine's limitations.
Okay, break it down for us.
If your daily workflow consists of web browsing, answering emails, writing documents in Google Docs, and streaming video on the couch by the Neo right now.
Yeah, that makes sense.
For $599, you're getting a premium aluminum unibody, a gorgeous billion-color screen, and 13.5 hours of battery life. The Neo is not trying to be a professional video editing rig or a gaming powerhouse.
Right.
Its strict limitations, like the lack of high-speed ports and the memory ceiling, are exactly what allow it to be so hyper-focused and affordable.
But what about the Mac Mini?
Well, if you are setting up a dedicated home office and you don't need the screen and battery portability, the $599 Mac Mini gives you twice the RAM and a much faster, actively cooled M4 chip for the exact same price.
It's just incredible to step back and look at the glorious absurdity of what the MacBook Neo actually is.
It really is something else.
We are talking about a computer with a literal smartphone brain. It features a retro 20-year-old USB port sitting right next to a cutting-edge one.
Yeah.
It has a stunning billion-color display. It relies on 18 individual screws and a battery tray to keep its chassis from bending in half, and it packages all of that into a fun, citrus-colored aluminum shell for $599.
It is a machine built entirely on profound contradictions, yet it somehow works perfectly for its intended audience.
And looking at the sources you provided, it leaves us with a really provocative thought to mull over.
Oh, yeah.
If today's $599 budget laptop runs effortlessly on the exact same silicon as yesterday's $1,000 Pro smartphone, what happens in 5 or 10 years? What happens when physical computing hardware becomes so cheap to manufacture and so incredibly powerful that it's practically an afterthought?
That is wild to think about.
Right. Are we rapidly approaching a future where the physical device itself doesn't even matter anymore, and we're simply paying a subscription fee for the AI and the software ecosystem living inside it?
That is the trillion-dollar question hanging over the entire hardware industry right now.
Something for you to think about the next time you're sitting in a coffee shop looking at the laptops around you. Thank you for joining us on this deep dive. Keep questioning the tech in your everyday life, and we will catch you next time.